Hello and welcome to time series forecasting. In this series of the lectures, I'm talking about intervention variables using the concept of dummy variables. In the previous video, I talked about including dummy variables during the periods when we intervene in the market by introducing a dummy variable equals 1 during the intervention and 0 otherwise. Now there could be three cases that can occur and we need to model those three cases differently. The first case is if the intervention lasts only for one period or only a few periods, and this is the example that I talked about in the previous video, where our ad expenditures went up only for few periods only. Looking visually, the effect will look something like this. We have our yt variable and we are plotting this variable against time, and we see that our variable was having a slope of beta I, and then suddenly we intervene in the market. For example, this is a period of time where our ad expenditures went up, and suddenly we saw that the value of the sales variable went up as well, and then the increase in the ad expenditures lasted until this period, and then our sales went back to our normal sales, and we are on the normal trajectory. So one thing to note here is that before we intervene in the market, our slope coefficient was equal to beta I, and it changed during the intervention. That is why we are including a dummy variable in our regression model to show that this is the period of time of intervention. And then we have our slope beta j after the intervention. Now, in this first case, case 1, we see that our slope before the intervention and after the intervention is identical. That is, our slope coefficient beta I, that is the slope coefficient before the intervention, and the slope coefficient beta j after the intervention, they are identical. Our sales only increased during the intervention. During this period of time, the slope was different, but we came to the normal slope after we stopped intervening in the market. So this is the first case. It can also happen that our intervention may be permanent in nature. That is, we increased our ad expenditures permanently. That is, this was our slope before the intervention, and this is our slope after the intervention. We will slice our data into parts. We will denote the time period before the intervention by 0, and since this intervention is permanent, so this will be denoted by 1. So now our binary variable or dummy variable take on a value of 0 before the intervention and 1 after the intervention. But look here closely that even now our slope beta I and beta j are identical, only the level of sales change, but we are not seeing any change in the slope. The slope here is identical to the slope coefficient here. Thus, even in this case, the slope is the same. Now, in both of cases 1 and 2, we are still using the linear model. Now let's look at another case where the slope coefficient will change. So looking at this graph, we see that we have a variable yt. We increased our ad expenditures and our slope coefficient was beta I before the intervention, and it was beta j after the intervention. Note here, beta I is not equal to beta j. Before the intervention, the slope is much flatter, and it is much steeper after the intervention. Now, this is an example of a nonlinear model that I will talk about later in this chapter. You cannot model this type of data using the type of models that we are talking about so far. These type of models need their special treatment or special tools. Alright, so this is the way of introducing dummy variables using intervention variables, and essentially introducing a dummy variable depends on whether the effect is transitory, it's permanent, or whether it changes the slope, and you will introduce a dummy variable accordingly. Alright, I'll see you in the next video. Bye bye.